Okay, next up is Dalton's law. Dalton's law of partial pressures. Okay, I'm going to write out the kind of long, sleepy definition, and then we'll talk about what it means. The sum of individual pressures individual pressures of gases. There we go. I should slow down. In a container is equal to the total pressure in the container. Okay, so let me kind of draw a picture of what that means. So I'm going to draw 3 containers, and really what I'm doing is drawing the same container 3 times. It's just a box, okay? And it is the exact same container. I'm just going to fill it with 3 gases 3 different times. Don't they look exactly the same? I guess if I was smart, I could use copy and paste, but I'm not smart. Okay. So in this one, I'm going to put gas 1. Doesn't really matter how much I put in there. The pressure in this container is P sub 1. That's the pressure of gas 1 in the container. Now I'm going to empty that container, put gas 2 in it. The pressure in, yeah, I know my gas has leaks, or my container has leaks in it, but that's okay. We'll ignore those. The pressure inside the container when it's filled with gas 2 is P sub 2. And guess what? Put some gas 3 in there. The pressure in here is P sub 3. All right. Now we are going to take that same container and we are going to put gas 1 in it. We are going to put gas 2 in it. And we are going to put gas 3 in it. And if I want to know the total pressure inside that container, P total is equal to P sub 1 plus P sub 2 plus P sub 3. And what are all those values called? Those are the partial pressures. Okay. Basically what's going on here is the gases mix completely and they don't know that the other gases are in there. So instead of having 3 individual or 3 gases behaving individually, it's like we just have 1 mole, or I'm sorry, 1 gas in there, and the sum total, the number of molecules, it doesn't matter what their identity is, that tells us the total pressure, okay? So let's just summarize that in words, and we'll say that the total pressure only depends, that's French, depends on number of moles of gas, not the identity of a gas. Okay, so it doesn't matter what gases we put in there. It could be helium, nitrogen, oxygen, or it could be fluorine, radon, and hydrogen. They all behave the same, and it gives us the same total pressure. Okay. So we have an equation for this, or I'm sorry, this gives us another equation. I'm not going to go through the derivation, but we get something that we call the mole fraction. And mole fraction is an important concept that comes up over and over and over again. And mole fraction is given the abbreviation X, and it has no units. And you'll see why it has no units. So the mole fraction of, say, gas 1 in our example up there is equal to the number of moles of gas 1 divided by the total number of moles of gas. So let's annotate that. That is the moles of gas 1. That is the total number of moles of gas, and then that is the mole fraction of gas 1. So the reason it has no units is because moles divided by moles. So moles here, moles divided by moles gives us a unitless number. And something else, X is always, mole fraction is always, well, I'll just say it, it's always less than 1. Because it's a fraction, it's really a decimal. It's usually how we give it, but again, number of moles of gas 1 divided by the total number of moles, that's always going to be a number smaller than 1. If we multiply this by 100, it just gives us a percent. Okay, so let's just do a real quick example using that mole fraction concept. In the next video, I'll do another Dalton's law example. What is the partial pressure of O2 at sea level if 21% of the atmosphere is O2. Oh, I forgot to give you another equation that derives directly from that mole fraction equation. Sorry about that. I'll just give it to you right now. Partial pressure of gas 1 is equal to the mole fraction of gas 1 times the total pressure. So basically we can interchange pressure and moles in these equations. So that's the partial pressure of gas 1, mole fraction gas 1, and that's the total pressure. And what units do we need for pressure? Doesn't matter as long as they match. Okay. So let's just solve this problem really quickly. Very, very simple problem. But we're given a we're trying to find PO2. And we're given a mole fraction of O2, and then we're going to multiply it by the atmospheric pressure at sea level. Okay. So our mole fraction is just 0.21. What does that come from? That comes from the percent. Okay, just divide by 100. And what's atmospheric pressure at sea level? Normal atmospheric pressure? It's just 1 atm. So what is the partial pressure of O2 at sea level? It's just 0.21 atms. Okay, hopefully you guys got that. Next video, another Dalton's law example.